Students, once again welcome to another lesson from iCampSA. In today's lesson we're going to be doing trigonometry, and the area of focus basically it's just an introduction for trigonometry mathematics, and the grade is grade 10. Without wasting any more time, let's get into it. Okay, so before we get started, let's quickly cover what is actually meant by the word trigonometry, so that we can lay some understanding of what we are going to be dealing with as we move forward with trigonometry. So, in simple terms, trigonometry is the study of the relationships between angles and the lengths of the sides. I want you to pay good attention in the word angles and the lengths of the sides, or we can just say is the study of relationships between angles and sides of triangles. The area of focus, we will be dealing with triangles. As you can see with the word tri, in trigonometry, tri means three, and triangles are three-sided polygons. So basically we'll be assessing or exploring the relationships between the angles that we find within the triangles and the lengths of the triangles. Okay, so first thing first, we have right angled triangles, which is what we're gonna be focusing on, and I would like to believe that those has been introduced for you in grade 9 or grade 8. Okay, so right angle triangle, the way that we see right angle triangles is by that 90 degrees angle. They have a 90-degree angle, and then two other angles of which they can be any other complementary angles, so the way that we see right angle triangles is by as I've just mentioned, is the 90 degrees angle that we find within the right angle triangle. It has that 90-degree angle and then two other angles. Remember that these two angles, they are less than 90 degrees. Angle A is less than 90 degrees and angle B is less than 90 degrees. But when we add them, they are also equal to 90 degrees. Why? Because the angles in a triangle are supplementary, or they are equal to 180 degrees. So those two angles, when we combine them, they're also equal to 90 degrees, but on their own they are less than 90 degrees, in order for this to be a right angled triangles. Okay, and then so when we're dealing with right angled triangles, there is a theorem of Pythagoras, of which I would like to believe has already been introduced to you. So the theorem of Pythagoras says the longest side of the right angle triangle, of which we call the hypotenuse side, squared is equal to the sum of the squares of the other two sides. So in writing, as you can see here, that the longest side, which is C, and another thing about right angle triangles, the longest side will always be the hypotenuse side. Let me quickly write here, this is the longest side, of which is the hypotenuse side, and it is facing the 90 degrees angle. Okay, so the square of the hypotenuse is equal to the square of the other, is equal to the sum of the squares of the other two sides. Let me use a different color to highlight. Is equal to the sum of the squares of the other two sides, of which is, in this case, is side A and side B. So that is the theorem of Pythagoras, and then we can actually rearrange this to make side B to be the subject, of which we'll now end up having what? If we make side B the subject, we'll end up having B squared is equal to C squared minus A squared. That's another form. Let's say we are asked to determine the side B. That is the equation that we can use, and then once again we can rearrange this Pythagoras theorem, or the theorem of Pythagoras, in order to make A to be the subject, and then we'll have what? A squared is equal to C squared minus b squared. We just take the b squared to the other side, so that is basically the theorem of Pythagoras. And yeah, we are going to use it a lot to solve for the sides. Maybe if we are given two sides, we can find the third side. That's the beauty of the theorem of Pythagoras. And then as we dive in deeper into trigonometry, we'll introduce trigonometric ratios that now we can use to relate the sides and the angles within the triangle. Let's get into it. Okay, so with the right angle triangles, they have three distinct sides. Already I've talked about the hypotenuse side. The hypotenuse side, as I just the side that is facing the 90 degrees angle, the 90 degrees angle. Let me quickly write that down. That hypotenuse longest is the longest side, and it faces longest side facing the 90 degrees angle. That is how we see a hypotenuse side. And then we have the other two sides, is the opposites and the adjacent side. And then the opposites and the adjacent side, they depend on which angle we are dealing with. So for example, in the first triangle, let's look at angle number B. So for angle number B, the side that will be opposite to angle number B is going to be side AC, and hence why this is the opposite side. And then we have the adjacent side, which is the side next to the angle we are focusing on. So the side CB in this case is the side that is adjacent to B. So on the other hand, if we are focusing on angle A, let's now go to the second diagram. We are focusing on angle A. The hypotenuse side is still gonna be the longest side, and it's still gonna be the side that is facing what you call this thing, that is facing the 90 degrees angle. That's the hypotenuse side. But now, which side is next to the angle A? Now it's gonna be side AC. That we see here. Therefore, this will be now be our adjacent side. Because it's the side that is next to the angle we are referring to. In this case, is the side is the angle A that we are referring to, or we are looking at. Therefore, the side that is adjacent to angle A is side AC. And then the side that is opposite, facing the angle we are dealing with, is gonna be side CB. So it's gonna be this side. So I hope you guys do understand in terms of the adjacent and the opposite side. That those two, they depend on which angles we are dealing with. So yes, that is that for now. It's the opposite side, hypotenuse side, and the adjacent side. Let's go ahead now and talk a little bit about trigonometric ratios. Remember, we said trigonometry is the study of relationships between angles and the lengths of the side. So trigonometric ratio, what are trigonometric ratios, or when do we actually use the trigonometric ratios? So trigonometric ratios are used to define the relationships, what we are studying, between sides and angles. So as you can see now, that in order for this study of trigonometry to be performed, we need to use those ratios. We call them trigonometric ratios. So we have three basic trigonometric ratios. As you can see listed there, we have the sine trigonometric ratio, we have the cosine trigonometric ratio, and we have the tangent trigonometric ratio. Those are the three special trigonometric ratios that we use in order to define the relationships between the sides and the angles of a triangle. Okay, let's quickly look at the triangle that's at the sketch that we have drawn here. So for this sketch, we have the hypotenuse side facing the 90 degrees angle, and then we have the angle of focus here will be angle theta, which is angle B. But we'll just call it angle theta in this case. And then let's look at the side opposite to angle theta. Is gonna be what side? it's gonna be side AC. It's gonna be side AC. That will be the side opposite to angle theta, and the side next to angle theta will be side CB. That will be the side that is adjacent to angle theta. Okay, how do the trigonometric ratios actually work? So for the first one, we say the sine of an angle theta, the angle theta we're dealing with, is equal to the length of the opposite side. So it's equal to the length of the opposite side. So a sine of an angle theta, the angle theta we're dealing with here, is equal to the length of the opposite side over divided by the length of the hypotenuse side. So in simple, sine theta is equal to the opposite side over the hypotenuse side. So let's quickly go back to our diagram there that we have sketched there. So if we were to be asked to find the trigonometric ratio, or the sine of theta in reference to the diagram that we have there by using AC and B, so what is gonna be sine theta? So for this triangle that we have here, sine of theta, we said it's the opposite side, or the length of the opposite side over the hypotenuse. So what is the side that is opposite to theta in that diagram that we have here? It's side AC over the hypotenuse side. What is the hypotenuse side in this triangle? The side that is facing the 90 degrees angle is side AB. So sine of theta for this particular diagram is going to be AC over B. It's going to be AC over B. Okay, so that is basically the sine trigonometric ratio. So sine theta is equal to the opposite side, or it's the ratio of the opposite side to the hypotenuse side. So that is how the sine trigonometric ratio is defined. Okay, and then let's quickly go to the second one, which is the cosine trigonometric ratio. So a cosine of an angle will now look at what? We look at the length of the adjacent side. Over the length of the hypotenuse. So I want you to pay attention to what is happening. For both the sine and the cosine trigonometric ratio, we divide by the length of the hypotenuse side. So the denominator is common. It's always going to be the hypotenuse side for the sine trigonometric ratio, and then the cosine trigonometric ratio. Okay, so cosine of an angle theta is equal to the length of the adjacent side over the length of the hypotenuse side. Okay, so in simple, therefore, cosine theta is equal to adjacent over the hypotenuse side. Once again, let's go back now to our sketch and find the cosine of theta for this triangle that we are dealing with here. So we are saying cosine theta is the length of the adjacent side. What is the side adjacent to theta now? Is going to be side CB. This is the adjacent side, and then the hypotenuse side once again is still going to be AB. So therefore, in other words, cosine theta is going to be CB, length of the adjacent side CB, over the hypotenuse side, which is AB. And that is basically the second trigonometric ratio. So we are dealing with the adjacent and the hypotenuse side, or the ratio of the cosine of theta is the adjacent over the hypotenuse side. Hopefully that makes sense. And then thirdly, we have another special trigonometric ratio, which is the tangent. So let's go ahead and quickly look at what happens when we are looking at the tangent of theta of an angle theta. So for the tangent of an angle theta, the ratio will be the opposite side length, or the length of the opposite side, over the length of the adjacent side. As you see here, it's going to be the opposite side length over the adjacent side length. So for the tangent, we are now not we do not deal with the hypotenuse, but we only focus on the opposite side and the adjacent side Okay, so let's quickly come here and determine for this triangle that we have here. Let's determine the tangent of the angle theta that we have there. So we said, so in other words, therefore, tan theta is equal to the opposite side over the tangent over the adjacent side. So let's quickly determine the tangent of theta for this triangle that we have here. What is the opposite side? What is the side opposite to theta? Is side AC over the adjacent side, which is side CB. Therefore, the answer here is going to be side AC, the opposite side over side CB. So that is basically the tangent of an angle theta, and that is how the ratio is determined. It's the opposite side over the adjacent side. It's the opposite side over the adjacent side. Okay, so there is a way to actually memorize, there is a way to quickly memorize the trigonometric ratio, and we use this mnemonic that you see here, which is SOHCAHTOA. It's SOHCAHTOA, and then as what does this letters means, so you can quickly memorize them. SOHCAHTOA. So the first the first letter, or the first letter in SO stands for the sine. That means we are dealing with the sine trigonometric ratio. And then the first letter in the second abbreviation, which is C, stands for cosine, which means we are dealing with the cosine trigonometric ratio. So with SO, what do we have here? We have the opposite side, and this one stands for the hypotenuse side. This one is for the sine, trigonometric ratio. And then we go to we have what? Cosine. We have cosine, and then when we are looking at cosine, what are we dealing with? We're dealing with the adjacent side, and the hypotenuse. And then lastly, we have TOA, which is the tangent, and then when we're looking at the tangent of an angle, what the ratio are we looking at? Is the opposite side over the adjacent side. So opposite side over the adjacent side. So you should memorize this, just in case you forgot in the exam, which ratios are we looking at and which sides are we dealing with when maybe we are dealing with the cosine of an angle. This will help you to memorize that. So it's SOHCAHTOA. Okay, SOHCAHTOA. And then next, so what you will see happening in the exam, you won't be given or you may be given a triangle like this, but you'll see that now the opposite side, or side AC, will have maybe exact numbers. We will have exact, maybe it's 7, and then you have the adjacent side maybe being 8, and then you'll have to, you can calculate the what you call this thing, you can calculate actually the angle theta. You can calculate the angle theta, and what do you do? Or you can calculate the trigonometric ratio using those two sides. So for a given angle, the sine, the ratio, trigonometric ratio, sine, cosine, and tangent can be calculated with the use of a calculator. So basically, you're just going to be using a calculator to perform the following, to calculate the ratios for sine, cosine, and the tangent. If you are given, let's say, maybe angle 30, so what you're gonna do, you're gonna go into your calculator and punch sine, open bracket, 30, close brackets, you punch the equal sign, and that should give you the ratio. For that sine of the angle 30, Okay, so let's quickly do this example here. Just as a practice of what we have just done now. So given the following triangle, So it's triangle ABC with the angles that you see, the angle theta, and then we have angle alpha, and then the respective sides. So the sides are labeled PQR. So first thing first, let's determine which side is the hypotenuse side. The side that is the hypotenuse side is gonna be Q. Is gonna be Q. Why? Because Q is the side that is facing the 90 degrees angle. And then the opposite and the adjacent side will depend on which angle are we looking at. So what does the question ask? It says states the following in terms of PQR. So we have to state the following trigonometric ratios in terms of what? In terms of PQ and R. So sine theta, that's the first one. So sine of theta, we are looking at this angle here, angle theta. What is sine theta? Sine theta, we know that is the opposite. Soccer is the opposite over hypotenuse. It's the opposite over hypotenuse. So let's quickly come here and answer this one. So sine of theta, sine theta is equal to opposite side over hypotenuse side. Therefore, what is the opposite side? We know the hypotenuse is gonna be Q, but what is the side opposite to angle theta? The side that is facing angle theta, and that is side P. Therefore, sine of theta is gonna be P over the hypotenuse side Q. And then next, cos of theta. And we know that cos is what? What is cos? Cosine is the adjacent side. Cosine is the adjacent side over the hypotenuse side. Cosine is the adjacent side over the hypotenuse side. So cos of theta is the adjacent side over the hypotenuse side, which will be, in our case, which side is adjacent? Adjacent means next to. Which side is next to the angle theta? For our case here, it's gonna be side R. Therefore, we're gonna have R over cos theta is equal to R over Q. And then next we have tan theta. What is the ratio of tan theta? When we're looking at the tangent, the ratio is the opposite over the adjacent. So opposite over the adjacent. So tan theta is gonna be opposite over adjacent. What is the side opposite to theta in our sketch there? The side opposite to theta is side P, and the side next to angle theta is side R. Therefore, this is gonna be equal to P over R. This is P over R. Okay, and then next we are now dealing with sine alpha. Sine alpha, opposite over hypotenuse. Sine alpha is the opposite over hypotenuse. We need to look at the side opposite to angle alpha now. Angle alpha, the side opposite to angle alpha is gonna be side R. Therefore, we're gonna have R over, what is the hypotenuse? Hypotenuse is always gonna be the side that is facing the 90 degrees angle, so it's gonna be R over Q. And then cosine alpha, for the trigonometric ratio of cosine is what? Adjacent over hypotenuse. So cos alpha is equal to what? Adjacent side over the hypotenuse. What is the side that is adjacent next to alpha? Angle alpha now is what? Is side P. Therefore, we're gonna have P over Q. Still hasn't changed the hypotenuse, And then next we are looking at tan alpha. Look at the tangent. So for tan alpha, we are looking at the opposite over adjacent. which side is opposite to alpha now? Side this is facing alpha is gonna be side R, and the side is next to alpha is P. Therefore, tan alpha is gonna be R over P. R over P, opposite over adjacent. Opposite over adjacent. I hope you guys do now understand how the trigonometric ratios work. Okay, and then next, let me see. Okay, we are given the following triangle. So this triangle has the sides 24 centimeters and the side 10 centimeters, and then it has the angles, the angle alpha there and the angle theta there. So we are asked to determine the length EF. Determine the length EF. This length here, the length of this side. What do we know about the length or the side EF? Side EF is essentially the hypotenuse, because here we are dealing with a right angle triangle, and we can see that EF is facing the 90 degrees angle. So we can find side EF by using what now? The theorem of Pythagoras, which says the square of the hypotenuse side is equal to the sum of the square of the squares of the other two sides. Okay, so we're gonna use the Pythagoras theorem in order to solve this, in order to determine. Let me do it like this. In fact, gonna use the hypotenuse side. Okay, determine the length EF. So EF is the hypotenuse side, so we're gonna say the square of the hypotenuse side EF is equal to the sum of the other side, which is EG squared plus FG squared. But we already know what is length EG. We've been given is 24 centimeters squared plus what is side FG is 10 centimeter squared, 10 centimeters, and then we square those. We have EF here, EF squared. Therefore EF squared is gonna be equal to 24 squared. Let me quickly get my calculator. So 24 squared, to punch it in your calculator, is gonna give you 576 plus 10 squared is 100. Let me move this to here. Okay, therefore EF squared, what is 576 plus 6 plus 100? Therefore EF squared is gonna be 676. And then what do we do next? We introduce square roots on both sides. Square roots on both sides. Therefore EF is gonna be square root of 676, of which is 26 centimeters. Is 26 centimeters. Okay, and then what did we use here? Let me quickly label. This is the theorem of Pythagoras. That is the theorem of Pythagoras that we use there. Okay, next, write the value of sine theta, cosine theta, and tan theta. Okay, so we already know that the side EF is what? Is 26 centimeters. So we can evaluate those. Let me quickly move number C to here. So for sine theta, what is the ratio of sine theta? Is gonna be opposite side over the hypotenuse side. So it's opposite side over hypotenuse side. which is equal to, what is the opposite side in this? What is the side that is opposite to theta? It's gonna be the side with 10 centimeters. This is the side FG, which is 10 centimeters, over the hypotenuse side, which is 26 centimeters. So we're gonna have 10 over 26, 10 over 26 centimeters. Therefore, what is 10 over 26 simplified? I think it's gonna be 5 over 13. 5 over 13. And then next we have to determine, write down the value of cos theta. Cos theta we know is adjacent side next to the angle, over hypotenuse side. What is the side adjacent to theta? It's gonna be this side here, side 24. That is the side adjacent to theta next to angle theta. So it's gonna be 24 over hypotenuse, 24 over the hypotenuse side, which is 26. Therefore we're gonna have, I think it's 12 over 13. Simplify. So even if you leave it like this, in fact, let's just leave it like this, so that you can see what we are referring to. There is no need to simplify, but if you do, it's still correct. And then next we have tan theta. What is tan theta? It's SOHCAHTOA, remember. So when we are looking at the trigonometric ratio for a tangent of angle theta, is gonna be opposite over adjacent. What is the side opposite to angle theta? Side facing theta is the side with 10 centimeters long, over the adjacent side, which is 24 centimeters long. So it's 10 centimeter over 24 centimeter. So we're gonna have 10 over 24. It's gonna be, I think it's 5 over 12. 5 over 12. Yeah, that one is simplified. Okay, so next let's now go and evaluate the following, which is sine alpha. First, we know that sine alpha, we're looking at the opposite side over the adjacent side, but now we're focusing on the angle alpha here. The side that is opposite to alpha is what now? Is 24 centimeters over 26 centimeters. This therefore is equal to 24 over 26, and then next cos alpha. What is cos alpha? Cos alpha is adjacent side over the hypotenuse side. Which side is now adjacent to alpha? Side FG, which is 10 centimeter, over hypotenuse, which is 26. So we're gonna have 10 centimeters over 26. That will be our cos alpha. And then lastly we have tan alpha, which is opposite over adjacent. The side that is opposite to alpha is 24 over adjacent, which is 10 centimeters. We're gonna have 24 over 10. 24 over 10. That is the value, or that is the ratio of tan alpha. Okay. And next, let's go to example number 2. So example number 2, with a use of a calculator, calculate the following rounded off to 2 decimal places where necessary. So we just have to evaluate the angles that we are given, to basically determine the ratios for the angles that we are given there. The angles that we are given. Let me try to make some space. I think we need to add a page here. Add a page. Okay. and then I will just take this to the new page. Still example number 2. Okay, and then just to create some space for what we are doing here. Okay, so we have to, as the instruction says there, that we have to use the calculator for this one. So you go into a calculator, you're gonna punch sine. It's usually the bottom parts of the buttons on the calculator if you're using Casio or if you are also using a sharp, but you quickly just gonna punch sine 26, you close bracket, and make sure that whenever you are using a calculator to evaluate the ratios for these angles, that your calculator is in degrees. Your calculator is in degrees. That D there, you have to set the mode to degrees, 2 degrees. So let me maybe quickly write that always set calculator to D, which is degrees, so that you're gonna get the correct answer. Okay, so let's quickly do this ones, and then we have to round off to 2 decimal places. What is sine 26? Sine 26 is 0,438. So sine 26 is essentially sine 26 degrees is equal to 0,44 to 2 decimal places, and then next we have cos 68. You punch in the calculator, you're gonna get cos 68 degrees is equal to 0,93, and then we have tan 34. You punch it as it is on your calculator, tan 34, tangent of 34 degrees is equal to 0,67. Next we have cos 36. Cos 36 is 0,809, round off to 2 decimal places. Cos 36 will be equal to 0,81, and then we have negative sine 30 degrees. Negative 4 sine 30 degrees. What you do, you must start by evaluating sine 30 degrees, and then you multiply it by that negative 4 later. So you're gonna have negative 4 into what is sine 30? Sine 30 is 1/2. Then you multiply negative 4 multiplied by 1/2 is gonna be negative 2. So this is equal to negative 2. And then once again here we have 12 sine 60. You see 12, you evaluate sine 60 separately. Sine 60 is √3/2, and then you multiply or you remove the brackets by multiplying. So I'm gonna say 12 multiplied by √3/2, of which would give us 6√3. That will be your answer there for number 6. And then next we have tan 54 plus 25. Tan 54 plus 25. So in this case, what you do, you simply add what is within the bracket. So what is 54 plus 25? Is 79 degrees. So and then you calculate the tangent of 79 degrees, of which will give us now 5.14, rounded off to 2 decimal places. And then next you have cos 70 over sine 20. So cos 70. Let's calculate that first. Cos 70 is gonna be 0,342 divided by sine 20. What is sine 20? Is 0,342. Therefore, this is actually equal to 1. Is equal to 1. Okay, and then next for number 9, we have 40 over negative 25 sine 45. So this is gonna be equal to we can start, let's say 40 over minus 25 into what is sine 45. Let's evaluate the trigonometric ratio first. Sine 45 is root 2 over 2. You can punch this in your calculator. You can start by maybe simplifying the bottom or the top. Either way, 40 divided by negative 25 into root 2 over 2, root 2 over 2 into 2 decimal places. This is gonna be equal to negative 2.26. Negative 2.26. So these types of questions are actually pretty straightforward, because you just go to your calculator and you punch what you are given. Let's go to number B of this example. Calculate with the use of a calculator the value of the following expressions. Okay, so for number 1, we have sine squared 25. Okay, so the way that you're gonna actually punch this expression or this trigonometric ratio, if you are given sine squared 25, you're gonna go into your calculator. It's sine 25 degrees, and then in brackets everything you square, plus cos of 25 degrees bracket you square. This is how you're gonna actually punch it in your calculator. It's gonna be looking like that. So what is okay, and then once you have this, you can basically punch everything in your calculator. So you have sine 25 squared plus cos 25, also that squared. So I'll just emphasize, be careful with the use of the brackets, be careful with the use of the brackets, and then you get 1. I want you to pay attention. We're dealing with the same angle here and with the same angles. Sine of 25 and cos of 25, we are getting 1. Okay, and then that is your answer. It's 1. Okay, next, what do we have here? So what we have next is sine squared 62 plus cos squared 62. As I said, the way you're gonna punch this in calculator, you say sine of 62 degrees, everything in brackets squared, plus cosine of 62 degrees, everything in brackets squared. You punch this in your calculator, and then you gonna get, let's quickly punch it in a calculator. You're gonna get sine 62 plus sine 62 squared plus cos squared. You're gonna get 1 again. Just pay attention to the angles. We have the same angles, sine squared of 62, cos squared of 62, same angles we are dealing with. And the next, what do we have? We have sine squared 34. Once again, this is gonna be sine 34, everything squared, plus cos 34 degrees, everything squared. And then you punch this in calculator. Once again, you get what? You get 1. So I want you to pay attention to something here. we are dealing with the same angles, so the sine squared, let's say we're just gonna say theta plus cos squared theta, and when we are dealing with the same, the square sine squared plus cos squared of the same angles, so sine theta plus sine squared theta plus cos squared theta, we are always getting the answer, which is 1. So you'll see when you get into grade 11, this is actually what we call a trigonometric identity. Let me quickly write it down for you. So always when you are dealing with the same angle, sine squared theta plus cos squared theta will always be equal to 1. So let's say you are in your exam and then you are asked to evaluate sine squared 25 plus cos squared 25. You're just gonna know that the answer will be 1, because this is something else we call a trigonometric identity, or a trig identity. But you will learn that in grade 11. So this is a trigonometric identity. This is a trigonometric identity. Sine squared theta plus cos squared theta is always gonna be equal to 1. Okay, so that is how you go about solving those. Next, it's another example, solving simple trigonometric ratios. Okay, so now we have to determine the size of angle theta in each of the following equations. So with this equation that we are given here, what do we have to do here? So we're given the ratios, as you can see, we're given the ratios, and then we have to now solve for the angle, so once again you're going to be using the calculator to solve for angle theta. So there are some steps you should follow, in order to solve for this using a calculator. So there is some sequence of steps that you should follow in order to do that. So in your calculator, let me quickly write here, solving for trigonometry steps. Okay, so let's start with number A. We want to make theta the subject, because that is how we solve for angle theta, or for any unknown variable, by making it the subject. So in order to take that sign, this away from theta, what you should do, you should go to your calculator and press shift, and then you will press sine. You will see, I want to put this in words. You will see that your sine will now have sine inverse, which is sine to the power of -1. So let me just say, to make theta a subject, on your calculator, press first step is to press shift, the shift button, it's shift, and then for other calculators, I know it's gonna be second function. You press shift or second function, and then yes, and the following will appear. Once you have pressed shift, and then you press the trigonometric ratio you are dealing with. Let's say you are dealing with the sine trigonometric ratio, this will appear now sine inverse, and then with the brackets, or cos inverse brackets, or tan inverse brackets. Okay, so this is what is going to appear on your screen. And then what do you do next? You insert not the angle now, but the ratio. You insert the ratio or the value of the ratio. This is the part that you now insert in the bracket. So next, insert the ratio, value inside the bracket, okay. So basically those are the steps that you follow in order to solve for angle theta. If you are given a ratio and you are asked to solve for the angle theta. Okay, now let's go ahead and actually answer the questions. Let me see something. I think I can move this to below here, and then let's move this one higher. Yeah, that should come before that, and then we can start solving. Okay, so first thing first, we have to solve for sine theta. I'll just write everything down here. So theta, to make theta the subject, theta is now going to be equal to sine. You press shift in order to change sine to the second function, sine inverse. So it's going to appear like that, open brackets. You insert the ratio. What is the ratio for this example we are doing here? Is 0.707, and then you punch this in your calculator. It should give you the value of theta. Therefore, the value of this angle theta is 44.99. We change that to 1 decimal place. It's basically gonna be 45 degrees. It's gonna be 45 degrees. Okay, and then next, we do the same thing. We are evaluating cos theta. We are evaluating theta, calculating the angle theta, not evaluating cos theta, but we're calculating the angle theta. For cos theta is equal to 0.5. So theta cos, we change cos into the second function, cos inverse, and then you insert the ratio, just like the way I've written here. It should appear like that, and that's when you press the equal sign in your calculator, it should give you the value of that theta, of which in my case is 60 degrees. It's 60 degrees. Okay, and then let's go ahead and evaluate the others. You just follow those steps that I've laid down for you. To make theta the subject, you say theta is equal to, press shift and then you press tan. It should appear like this. It's going to be tan inverse. You insert the ratio that we're given here, which is 4.123, and therefore you punch the equal sign. Theta, therefore theta is going to be equal to 4.123, 76.37 degrees, 76.37 degrees. And then next we have 2 sine theta is equal to 1.0 124. So here you don't start by just taking sine to the other side, but we have to start by getting rid of that 2 there. How do we do that? We divide by 2 on both sides. Therefore sine theta is gonna be 1.124 divided by 2. And then once we are here, we can make theta the subject by saying theta is equal to sine. You press shift, you press sine on the calculator, it should appear like this. You should have sine inverse, which, and then with the open brackets you insert the ratio, which we have now here, just like this. You punch in your calculator. This should give us the value. This should give us the value of theta. So we have sine inverse 1.124 over 2, close brackets. The value of this theta is 34.19 degrees. That's the value of theta there. Okay, let me add a page. And then next, let's find a value of, now it's cos 3 theta that we have there, cos 3 theta. So that 3 theta, they belong together. This is, that 3 theta is the entire angle that gives us 0.33. So when we change cos to cos inverse, we don't include that 3, but instead we're gonna leave it this side with 3 theta is equal to, you follow the steps to make cos inverse, and then you insert the ratio, which is 0.33. But we are looking for angle theta. Therefore we have to divide by 3 on both sides. Whatever the answer we're gonna get from cos inverse 0.33, we divide by 3. Therefore theta is gonna be the value of theta, cos inverse 0.33 and by 3. The answer is 23.57 degrees. That is the answer. Okay, and then here we have 3 cos theta. It's almost similar to what we did in D. We want to isolate theta. First step, we divide by 3 on both sides. This one will cancel this. We will be left with what? We will be left with cos theta is equal to 0.33 divided by 3. And then to make theta the subject, we need to take cosine to the other side. Therefore we're gonna have theta is equal to cos inverse. Following the steps, you press second function, or you press shift, you press cos, it should give you what we have there, cos inverse, and then you insert the ratio, which is 0.33 over 3, and therefore we calculate the value of theta. Let me move this one a little bit down. Therefore the value of theta here is, quickly calculate the shift, cos 0.33 over 3 is 83.68 degrees. 83.68 degrees. Okay, and then next we have tan for theta is equal to 4 degrees. Is equal to 4. It's not 4 degrees, it's equal to 4, just 4. It's the angles that have degrees, not the ratios. The ratio, they don't have degrees. Okay, so first step into solving for theta here, we're gonna take the tan to the other side, so 4 theta will be left with 4 theta, and then we have tan inverse of 4, we insert the ratio, and then 4 theta, we calculate the tan inverse there, shift tan inverse of 4, it gives us 75.96 degrees. You then divide by what? You divide by 4 on both sides, because we are not solving for 4 theta, but we are solving for theta and theta alone. So that divided by 4 is gonna give us now 18.99, and that is your answer. Theta is 18.99 degrees. Okay, so that is how you would go about solving that. And then next we have 4 tan 4 theta is equal to 4. Okay, so solve for theta in this one. What do we have to do? We have to start by removing that 4, so we divide by 4 on both sides. This 4 will cancel that 4. What we will be left with on the left side is tan 4 theta is equal to 4 divided by 4 is 1. So once we are here, because this 4 theta, all of that is actually the angle, so we don't touch it. We're not gonna be now dividing by 4, but we have to take the tan to the other side following the steps I've introduced for you. Therefore 4 theta is equal to tan inverse 1. We evaluate that. Shift tan 1 is 45. Therefore 4 theta is equal to 45 degrees, but we are looking for theta. Therefore we divide by 4 on both sides. Therefore theta is equal to 45 divided by 4, of which is, we can leave it like this, but we can turn it to decimal, which is gonna be 11.25 degrees. And that is gonna be your answer. Hopefully you guys do understand how we go about solving those. Okay. Next. Okay, so it's another example. So example number 4, solve for angle x in each of the following and round off your answers to 2 decimal places where necessary. Okay, before we get there, let me add a page. I suspect we're gonna need a page. Create. Okay, so that is example number 4. We are solving for x now, angle x. So any variable can be used to represent the angles, but normally what you will see happening is that they will use the Greek letters that we have already used, which is theta, beta, and what is this, the other ones, alpha, gamma. Those are the Greek letters that they normally use, but also the alphabets as we are used to them, they can also be used. Okay, so here we are solving for x. So for number 1, sine x minus 20 degrees is equal to 0.678. X minus 20 degrees, this is the angle, and this is the ratio. First thing first, what do? We isolate the angle. The angle is x minus 20 degrees. Take sine to the other side, we're gonna have sine inverse. We insert the ratio 0.678 degrees. Okay, therefore x minus 20 degrees is equal to, let's evaluate sine inverse 0.678. That is equal to 42.69 degrees. And then we take 20 to the other side, so we're gonna have x is equal to 42.69 degrees plus 20 degrees, of which x, therefore x will be equal to 42.69 plus 20, that is 62.69 degrees, and that will be the value of x. That will be the value of x. Okay, and then next let's solve for x once again. Okay, so here we have 3 cos x plus 30 degrees is equal to 2.121. X plus 30 degrees is your angle, all of that, and then 2.121 is the ratio. Okay, so first thing we have to isolate the angle. So, and we have the 3 there that is adjacent to cos of the angle. We start by removing the 3. So in order to remove it, we have to divide on both sides by 3. We divide on both sides by 3. Therefore, we're gonna be left with cos of x plus 30 degrees is equal to 2.121. And then let's isolate the angle now. Therefore, we're gonna have x plus 30 degrees is equal to, we take cos to the other side, so we're gonna have cos inverse of this is over 3, 2.121 divided by 3, 121 divided by 3. We evaluate that with the calculator, and then x plus 30 degrees is equal to cos inverse 2.121 over 3. That is equal to 45 degrees, is equal to 45 degrees. We take the 30 to the other side, therefore x is equal to 45 degrees minus 30 degrees. 45 minus 30 is 15 degrees. That is the value of x, 15 degrees. Okay, and then next let's do number, we have another page. Let's do number 3. So for number 3, we have 2 tan into 2x minus 10 into 2x minus 10. What is our angle? 2x minus 10. All of this is our angle. 3.4641 is our ratio. Okay, so first step, when we have the coefficient there, which is 2, remove the 2, and then the way to go about that, we have to divide by 2 on both sides, and then we'll be left with tangent of 2x minus 10 degrees is equal to 3.4641 over 2. Okay, and then next we isolate the angle, so we're gonna have 2x minus 10 degrees. 2x minus 10 degrees, we take the tan to the other side, of which will be tan inverse is equal to 3.4641 over 2. Let's evaluate tan inverse. Therefore, we're still gonna, the angle is 2x minus 10 degrees is equal to what is tan inverse of 3.4641 over 2. That is equal to 59, or it's essentially 60 degrees. That is equal to 60 degrees. Let's solve for angle x. We take the 10 to the other side. We're gonna have 2x is equal to 60 degrees plus 10 degrees. Okay, and then what is 60 plus 10 degrees is 70, and then therefore 2x is equal to 70 degrees. We divide by 2 on both sides. Therefore x is equal to 70 divided by 2 is 35 degrees. That is 70 divided by 2, 35 degrees. Okay, hopefully you do understand that. And then next, let's do number 4. We are given what? 2 tan 2x is minus 10. And look at the use of the brackets there, that 2x minus 10 is not in bracket, so the 10 is just a separate expression. And you also see that that 10 doesn't have a degree sign there, so it's not part of the angle. What is the angle here? The angle is just 2x, and everything else is just separate. Okay, the goal is to isolate the angle, but in order to do that we need to remove the 10 and the 2 first. Okay, so we're gonna have 2 tan 2x. We take the 10 to the other side. This is equal to 3.4641 plus 10, and then we're gonna have 2 tan 2x is equal to, what is 3.464 plus 641 plus 10 is gonna be 13.4641. and then next is to isolate tan 2x. We divide by 2 on both sides. Therefore tan 2x is equal to 13.4641 over 2. Okay, and then next let's isolate what? Let's isolate 2x. Therefore, and then in order to isolate 2x we have to take tan to the other side. Therefore we're gonna have 2x is equal to tan inverse, following the steps I've laid, tan inverse of 13.4641 over 2. Let's evaluate that using our calculator. Tan inverse of 13.4641 over 2, that is equal to 81.55. Therefore 2x is equal to 81.55 degrees. We divide by 2 on both sides. Therefore x is equal to 40.778. It's 40.78 degrees. That's the value of x. And that is how you solve for x with equations that include trigonometric ratios. Your exams will be containing questions of this nature. So I would suggest that you practice more and you come back to this video and you watch the steps for solving these equations once again and again and again until they are engraved in your brain. Okay, so maths is a practical subject. You learn maths by doing it. Okay, that was example number 4. Okay, and then next we have special angles. So what are special angles? We're gonna be dealing with mostly these 3 special angles, which is 30 degrees, 45 degrees and 60 degrees, but we also have 0 degrees and 90 degrees. as you go into grade 11. Those would be introduced. But what makes these three angles to be special angles? These three angles we call them special angles because their ratios can be determined without using a calculator. So the trigonometric ratios of special angles can be determined without using a calculator, and this is why we call them special angles. And in order to do that, we have to make use of the the following two triangles. So the first one, special triangle, it's a triangle, right angle triangle, that has the angles 45 degrees and 45 degrees. Okay, this angle, and it has the sides 1 and 1, the side 1 and 1, and then therefore the hypotenuse side is root 2. That's the first special triangle, with the angles 45 degrees and 45 degrees. And then next we have another special triangle, and then this one has the angles 30 degrees and 60 degrees. The sides are gonna be 1 root 3 and 2, 1 root 3 and 2. Those are the sides of the second special triangle. So if you are asked to, let's quickly fill in the table to find the sine of 80 degrees, you simply come to your special triangle. Which side is facing 30 degrees is 1 over, what is the hypotenuse, is 2. So sine of 30 degrees is what? Is 1 over 2. 1 over 2. And then sine of 45 degrees is, what is side is facing 45 degrees is 1, and what is the hypotenuse side is root 2. So sine of 45 degrees is always going to be 1 over root 2. 1 over root 2. Okay, and then next we have sine 60. For sine 60, which side is facing the angle 60? Is root 3 over the hypotenuse, which is 2. Therefore sine 60 is going to be root 3 over 2. Root 3 over 2. And then next we have cos 30. Cos 30 is going to be the adjacent side over the hypotenuse. Adjacent side, this is angle 30. The side next to angle 30 is root 3 over the hypotenuse, which is 2. Therefore cos of 30 is going to be root 3 over 2. Cos 45 adjacent, both sides are equal to 1. So when we use this cos 45, the adjacent side is 1, hypotenuse is root 2. So cos 45 and sine 45, their ratios are actually equal or the same, which is 1 over root 2. 1 over root 2. And then cos 60 degrees, adjacent side over hypotenuse. So the side that is next to 60 degrees is 1, the hypotenuse side is 2. So therefore we're gonna have 1 over 2. And then next we have the tangent, the opposite side over the adjacent side. Let's start with 30 degrees. So tan of 30 degrees, we come here to the special triangle. The side that is facing 30 degrees is 1, and the adjacent side is root 3. Therefore tan of 30 degrees is going to be 1 over root 3. And then for tan 45 degrees, opposite side 1 over adjacent side is 1. So 1 over 1 is just going to be 1. And then next we have tan of 60 degrees. Tan of 60 degrees, opposite side over adjacent side. So it's root 3 over 1. Therefore it's just going to be root 3. It's just going to be root 3. So you see, that is how you go about evaluating the special angles, by using those two triangles that you see there. by using those two triangles that you see there. So you don't have to use a calculator to actually evaluate the special angles, which is 30, 45 and 60 degrees. You just use the triangles there. Okay, so yeah, that is that with special angles. So this lesson is already above an hour. What we gonna do, we gonna end the lesson here, and then on our next lesson we gonna be looking at the angles, once again doing examples of special angles, and then we gonna be looking at the angles of elevation and angles of depression. But this marks the end of today's lesson, and until we meet again, I wish you good luck and good studying.